Ultrasound waves are sound waves beyond the range of human hearing. Remember that a sound wave is a longitudinal wave created by vibrations in the air or other matter. We can represent them with a pattern like this, representing the compressions in the wave pattern. The range of human hearing is between 20 Hz and 20 kHz, so an ultrasound wave would have a frequency above 20 kHz. Any sound wave with a frequency above this can be referred to as ultrasound. Ultrasound waves will also have a short wavelength. This is because ultrasound travels at the same speed as any other sound wave, so if it has a high frequency, then it must also have a low wavelength to balance this out and keep to the speed of sound. You need to be able to define ultrasound waves both in terms of their frequencies and in comparison to sound we can hear. But what is ultrasound used for? Well, the properties of ultrasound waves make them useful for imaging and measuring distances. Now, these properties are mainly how the waves travel and behave at boundaries, but you don't need to be able to name these or explain why the waves have them. You'll only be asked about how processes like this one work. Let's suppose we need to use ultrasound to measure the distance to some object. We do this using a thin ultrasound pulse. This is a short ultrasound wave we use, as it won't spread out and the whole wave travels in a single direction, which makes its motion more predictable. When the ultrasound wave reaches the boundary with an object, it will mostly reflect and be sent back towards us. But how does this help us measure distance? Well, the distance to an object can be measured from the time it takes the ultrasound to be reflected and to return. Let's look at the path the ultrasound pulse takes. It first travels some distance to get to the object. Let's call this distance S. Then, to get back to us, it has travelled this same distance again. So overall, it will travel a distance of 2s. Now remember that speed is equal to distance over time, or distance equals speed multiplied by time. In this case, we can write that 2s equals vt, where v is the speed and t is the time taken. Now we already know what speed all sound travels at, and we can measure the time between when the ultrasound pulse is first produced and when it returns to us. So using these together, we can calculate this distance s. You'll need to be comfortable with how this process works, as at GCSE you need to know how it's used in a variety of contexts.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!